Okay, so in the previous class we have discussed about the conducting system. Today we shall discuss about a very important topic, that is cardiac cycle. So what is cardiac cycle? We know that our heart gets contract to pump the blood to the lungs as well as to the other body parts. So to pump the blood, the heart must gets contract. So that contraction, and after contraction the heart needs to get relaxed also. So the cycle which comprises of contraction and relaxation is called as the cardiac cycle, right? So what is cardiac cycle? The cycle that comprises of contraction and relaxation is called as cardiac cycle. So this contraction and relaxation will be over within a certain time period. We have to see the duration of the contraction as well as the duration of the relaxation. So the contraction of the heart is called as the systole, okay, and relaxation is called as diastole. Some pronounces it as systole also, okay. So to understand this entire cardiac cycle, first of all I will just draw a rough sketch of the human heart, okay. So first of all I shall be drawing a rough sketch of the human heart. Okay. Okay. Now these are the receiving chambers. This is what? The right auricle. This is the left auricle. This is right ventricle, and this is the left ventricle. We know that right auricle, it receives the DOB blood, and it receives the DOB blood from two vena cavas. One vena cava is called as the superior vena cava, which will be bringing the DOB blood from the upper part of the body, and one vena cava is called as the inferior vena cava, which will be bringing the blood from the lower part of the body. And there is one vein which opens into the heart itself, and that vein, it brings the DOB blood from the heart muscle itself, because the heart muscle will also be requiring oxygen, and the coronary artery supplies the oxygen to the heart muscle, and after the gaseous exchange takes place in the heart muscle, the DOB blood comes to the heart again by a vein, and that vein, it opens into a sinus. It opens into a sinus, and this sinus is called as the coronary sinus, right? And through the coronary sinus, the DOB blood will be brought to the right auricle from the heart. You can see that the left ventricle wall is very thick because it needs to pump the blood to all the body parts. The OB blood, that is the oxygenated blood, will be brought by the exceptional vein, and these veins are called as the what? Pulmonary veins. There are four pulmonary veins, two coming from each lungs, which will be opening into the left auricle. Okay, now first of all we will discuss about the, let me draw this chordae tendineae also, which will be attached with the papillary muscles to the valve, that is to the bicuspid as well as the tricuspid valve. These valves are the bicuspid valve, and this valve is the tricuspid valve, and this is the chordae tendineae. Okay, it will be present in both the side. Chordae tendineae, the papillary muscles. Okay, so first of all let's discuss about the first phase of the cardiac cycle, that is auricular systole. Auricular systole. Systole means contraction. Auricular systole. Okay. Now, when the wave of depolarization, or when the SA node will be generating the impulse, SA node is present just in the right hand side of the right auricle, or near to the opening of superior and inferior vena cava. Okay, in the conducting system I have discussed. So when the this SA node will be generating impulse, and when the action potential will run to the through the whole auricles, we'll discuss what is action potential, what is depolarization, what is repolarization in the ECG. But for now, when the SA node will be generating impulse, and after then that impulse, when it will okay, cover the entire auricular portion, then the auricle will get contract. So when the auricles will get contract, the blood that is, and it will get contract only after it is filled with the DOB blood and the OB blood. So when the right auricle is filled with the DOB blood and when the left auricle is filled with the DOB blood, then after then the auricles are going to contract. So when the auricles will get contract, then what are the changes that will be seen? Okay, we have to discuss this in auricular systole. So as soon as the auricle it contracts, then the blood will be pumped to the left and the right ventricle. The blood will be pumped to the left and the right ventricles. That means the blood will be pumped to the ventricles. So the first thing that we have to write is blood is pumped into respective ventricles. Blood is pumped into respective ventricles. Okay, so when the blood will be pumped to the respective ventricles, then these valves, that is a tricuspid valve and a bicuspid valve, which is also called as the auriculoventricular valves, these valves must open. Otherwise, how can the blood will come from auricles to the ventricles? So the second thing is that the left and right auriculoventricular valve, auriculoventricular valves are wide open. That is, which valve? The bicuspid valve and the tricuspid valve. Bicuspid and tricuspid valve. Tricuspid valve and the bicuspid. Bicuspid valve is also called as the mitral valve. So these valves must get open. Then only the blood will be able to come from the auricles to the ventricles. Okay. Now, when the auricles are going to contract, then there are valves at the inferior vena cava and there are valves at the coronary sinus. Now, I told that why the valves are present in the inferior and the coronary sinus, because whenever the auricles are going to contract, a pressure will be generated, and because of that pressure, the blood may get backflow, or the blood may get flow through the inferior and through the coronary sinus. So to prevent or to restrict the movement of the blood from the inferior vena cava and through the coronary sinus, the valves of this inferior vena cava and coronary sinus must get closed, and the opening of the superior vena cava also must get closed, right? So the next change that will be observed is that the valve of what? The valve that is present in the inferior vena cava is called as what? I told it in the class. It is valve of Eustachius or Eustachian valve. So valve of Eustachius, and the valve that is present in the coronary sinus will be called as what? Valve of Thobesius or Thebesius. Thebesian valve. It is also called as valve of Thebesius. So valve of Thobesius, valve of Eustachius of inferior vena cava, and Thebesian valve of the coronary sinus are closed, and the openings of the pulmonary veins and the superior vena cava will also be closed, right? So openings of pulmonary veins and superior vena cava are closed. So these pulmonary veins and the superior vena cava, they are devoid of valves, and the openings of the pulmonary veins and the superior vena cava are closed. So this is all about the auricular systole, okay? And the time that will be taken, the time period will be 0.1 second. That means within 0.1 second, all these events will be happening. The auricles will contract, the blood, the DOB blood will come from the right auricle to the right ventricle, and the OB blood will come from the left auricle to the left ventricle. These valves are going to close. That is the valve of Eustachius and valve of Tovesius, and the openings of the pulmonary veins and the inferior superior vena cava are going to get closed, right? So this is all about the auricular system. Now let's see about the ventricular system. Ventricular system. So once the ventricle is filled with the OB and the DOB blood, once it is get filled, and once the impulse travels from the AV node through the bundle of his to the left and right bundle of his and to the Purkinje fibers, and when the impulse will cover the entire ventricles, after then the ventricles are going to get contract. So what are the changes that will be observed during the ventricular systole? You see, so these valves, they get open during the auricular systole. That is the right auriculoventricular valve and the left auriculoventricular valve. But when the ventricles will contract, if these valves remains open, then the blood will get backflow from the auricles to from the ventricles to the auricles. So therefore, during the ventricular contraction, the auriculoventricular valves must get closed, right? So during ventricular systole, the first thing that we'll see is that a auriculoventricular valve, auriculoventricular valves closes. So these auriculoventricular valves will close now, and the closure of auriculoventricular valve will be producing the first sound of the heart, that is the lub. So auriculoventricular valve closes, and closure of auriculoventricular valves makes the first sound of the heart, which is lub, L-U-B, lub. Okay, lub, right? So the first sound of the heart it produces as a result of closure of auriculoventricular valves, right? Remember this thing. Next, what are the things that are going to happen? So these auriculoventricular valves will now get closed, and what are the structure that will be fixing this auriculoventricular valve at one position? Yes, these are chordae tendineae. Otherwise, the pressure is so much that the valve would have moved upward and the blood would have moved from the ventricles to the auricles. But these chordae tendineae will be fixing all these valves in the same position. Okay, right? Otherwise, the auriculoventricular valve would have become like this. Okay, and the blood would have moved like this. But the chordae tendineae, it will be fixing the auriculoventricular valves at one position, right? The second things that are going to happen, so as a result of the ventricular contraction, the blood will be brought from the right ventricle, the blood will be brought to the lungs by an artery, and this artery is the what? Pulmonary artery. And from the left ventricle, an aorta will arise, which will be bringing the blood to all the body parts, right? We know that our aorta, it turns left side. Okay, and just near to the this aorta, a pair of coronary artery will also arise. Okay, now as I told that the opening of the pulmonary artery and the opening of the aorta will be having certain valves, and these valves are nothing but these are the what valves? Semilunar valves. So when the ventricles will contract, the blood needs to flow through the pulmonary artery as well as the aorta, and therefore the semilunar valves should get open. So the second thing is that the semilunar valves of aorta and pulmonary artery is open, right? And the third thing is that about the duration. So the duration or the time period is almost 0.3 seconds, right? So these are the changes that will be taking place in the ventricular systole. And after the ventricular systole, the blood will flow to the lungs through the pulmonary artery and to all the body parts through the aorta and to the heart also through the coronary artery, right, which will be arising just near to the semilunar valve of the aorta. Now the last thing or the last phase of this cardiac cycle is the ventricular diastole. I will write here itself, okay, because I want to complete it in one page itself. So last is ventricular diastole or ventricular relaxation. Sorry, not auriculoventricular diastole. Auriculoventricular diastole, or you can also say as joint diastole. Joint diastole. This is the most perfect term, joint diastole. Okay, so joint diastole means both the auricles and the ventricles will get relaxed. So when the ventricles are getting contract, then already the auricles were at relaxed position only, but after the ventricles it gets contract, and when the blood will now start to flow or when the blood will now start to fill these auricles, so during that filling position, that means when the blood will start to come to the auricles again, so at that time the auricles will also be at relaxed position and the ventricles will also be at relaxed position. So these auricles and the ventricles, when they both will be at relaxed position, it will be called as joint diastole. So after the ventricles it get relaxed, or sorry, it get contract, the semilunar valve it was open and the blood was flowing through the pulmonary artery and the aorta. But and at the openings of the pulmonary artery and the aorta, I told that there will be semilunar valves. Now after the ventricles it gets contract and after it will start to relax, if these valves, if it do not gets closed, then the blood will again come from the pulmonary artery and it will again come to the right ventricle and the blood will again come to the left ventricle through the aorta. So this during the ventricular diastole, these openings, that is the valve that will be present in this opening, must get closed, right? So in the joint diastole there will be closure of semilunar valves, and this closure of semilunar valves will be producing the second sound, produces second sound of the heart, that is called as dub. Okay, so dub, it is the second sound of the heart, right, that is produced because as a result of the closure of semilunar valves, right? So the semilunar valves will get closed, right, which will be producing the second sound of the heart, right? And during this joint diastole, dub or dup, and during this joint diastole, the blood will start to fill the atrius, or the blood will start to fill the these auricles, and the time period of this joint diastole is 0.4 second. So you see, if I calculate the entire now cardiac cycle phases, the auricular systole is 0.1 second, ventricular systole it is 0.3 second, and joint diastole is 0.4 second. That means the contraction time period is 0.4 second and relaxation time period is 0.4 second, right? That means the heart is contracting for 0.4 second and it is also relaxing for 0.4 second, right? And the total time period, that is the total time period of the cardiac cycle, is 0.8 second, right? So this is all about the cardiac cycle. Hope you have understood. If there is any sort of doubt, please comment it in the comment box. Thank you guys.